Alright guys, this is section 5.5 that involves the trapezoidal rule. And in the first problem, they give us the integral pi sine of x, and we have to integrate from 0 to pi. And it says use the trapezoidal rule with n equals 4 to approximate the value of the integral. So you use use n equals 4, and then you plug in 4 for n, and then you do the table values, and you get this. Okay, and then use the equation, the trapezoidal equation, and you get t equals pi over 8 of 0 plus 2 times the square root of 2 over 2 plus 2 times 1 plus 2 times the square root of 2 over 2 plus 0, which approximately equals 1.896. That is the first part of the problem. For part 2, which asks, use the concavity of the function to predict whether the approximation is an overestimate or an underestimate, you do f prime of x equals cosine of x, and then you take the second derivative, and f double prime of x equals negative sine of x. So you need these two to estimate whether it's going to be what concavity it's going to have, and if it's going to be an overestimate or an underestimate. So the negative sine of x is less than 0 on the interval 0 to pi, and this approximation is an underestimate. Underestimate, my bad. Okay, so for part C, it asks us to find the integral's exact value. So this is simple. You just integrate sine of x, and then you get negative cosine of x because that's its antiderivative. From pi to 0, plug the values in, solve, you get 2. Alright, second problem. The question states, as the fish and game warden of your township, you are responsible for stocking the town pond with fish before the fishing season. The average depth of the pond is 20 feet. Using a scaled map, you measure distances across the pond at 200-foot intervals, as shown. Well, I didn't draw the diagram, but basically you don't need it because you just use the trapezoidal equation in the first part. And this is the trapezoidal equation, as you can see. So you know what the h and what the y naught and y1, y2 values are, and you just plug them in. H in this case is 200 because you're using 200-foot intervals, and h stands for the intervals. And then for y naught, y1, and y2, you plug in the values, and you get this 200 over 2 of 0 plus 2 times 520 plus 2 times 800 plus 2 times 1000 plus, and then you get here. And once you plug that in and solve for, you get 26,360,000 feet cubed. That's part A. Now part B, it says you plan to start the season with 1 fish per 1,000 cubic feet. You intend to have at least 25% of the opening day's fish population left at the end of the season. What is the maximum number of licenses the town can sell if the average seasonal catch is 20 fish per license? Okay, so to get this down on paper, you start with 26,360 fish, correct? And you intend to have, since they say you intend to have 25% of the opening day's fish population left, you multiply 75% times 26,360, because that would give you the leftover of 25%. So you have 19,770 fish to be caught, and the rest is the ones that they told us to have left. So since 19,770 divided by 20 equals 988.5, the town can sell at least, at most, 988 licenses. On to the next problem. So this one we have an integral of sine of x squared, of the function sine of x cubed, from the interval -1 to 1. And for the first part, it says find the second derivative of f of x, or f double prime, of the equation sine x squared. So in order to do that, we have the first derivative. We take the first derivative, which is 2x cosine of x squared, and then you take the second derivative of that, and you use the product rule with the chain rule inside, and this simplifies down to negative 4x squared times sine of x squared plus 2 cosine x squared. And that's the answer for part A. Now the part B says graph y equals f double prime of x. So once you do that, you get a graph that kind of looks like an upside down U or upside down parabola. So that's part B. In part C, it tells you to explain why the graph in B, right here, suggests that f double prime of x is less than or equal to 3 on the interval from that's -1 to 1. So, as you can see, f double prime of x is greater than -3 and less than or equal to 2. So therefore, f triple prime of x is less than or equal to 3 for for the absolute value of that. So that's what the question asked. If the absolute value of the double, oh, that's okay. That's why I was confused. That's supposed to say double prime, not triple prime. My bad. Okay, I was confused there for a moment. Yeah. So you have to say why the graph suggests that f double prime of x is less than or equal to 3, and you just look at the graph and you can tell that it lies above that, but once you look closer at the graph, you can tell that the graph suggests that f double prime of x is less than or equal to 3 for that interval. Alright, for part D. Show that the error estimate for the trapezoidal rule in this case becomes ET is less than or equal to h squared over 2. So use the equation that is the error bound equation, and for the trapezoidal rule up here, it is E of t, ET is equal, the absolute value of E of t is less than or equal to b minus a over 12 times h squared f double prime. So once you plug all of these values in, you get 1 minus -1, which gives you 2, all over 12, h squared from the equation, and that's the m value from the equation 3, which equals h squared over 2, and once you simplify it. And that's the answer for part D. So for part E, it says, show that the trapezoidal rule error will be less than or equal to 0.01 if h is less than or equal to 0.1. So you just plug in, well, you don't plug in, you solve for the equation, and once you solve the equation for h, if it's for it being between 0 and 0.1. So you put it into the equation, and you set it equal to less than or equal to 0.1 because those are the boundaries, 0.1 squared over 2, and you set that equal less than or equal to, and then you solve, and you get 0.005 is less than 0.01, and that there shows that the error will be less than 0.01 as they asked for. Now for part F, they say how large must n be for h to be less than or equal to 0.1. Now you solve this part for the n. So you put n greater than or equal to the absolute value of 1 minus -1 over h, and then you solve for that, and you get 2 over 0.1 is equal to 20, and that shows the value n must be for h to equal 0.1.